Alright, so today we're going to do a video on extreme values. And guess what, class? I actually just recorded this video, but since it was on the new computer, I didn't have the microphone turned on, so I just wasted about 30 minutes doing nothing. So I'm going to be especially surly doing this video, so you guys are going to be in luck. Okay, but anyway, so we're going to talk about extreme values. And so what extreme values are is basically when a function takes on a local maximum or a local minimum. So what I want you guys to do right now is just take a look at this function I put up right here. It's a function that is defined over a particular set of endpoints from A to B. And so what I want you guys to do is see if you can circle all of the local minimums and local maximums of this function. Pause the video and give it a shot. All right, so let's first look at the local maximums. Let's see what you were trying to find. Well, if I was going to point out the local maximums, I would say that looks like a local maximum. That looks like a local maximum. That looks like a local maximum. And we also have, don't forget the endpoints. The endpoint right here at A is also a local maximum. Remember, a local maximum is if it's higher than everything else in its immediate neighborhood. All right? So where did you find the minimums? Where I'd say the minimums were right here, right there, right here, and yet again we have an endpoint. An endpoint is a minimum. Okay? So those are our maximums and our minimums. So we're in a calculus class. We've been talking about derivatives for a while, so why am I bringing this subject up right now? Well, see if you can notice anything about every one of these maximum or minimum points, and if you can see any patterns in the first derivative of the function at those points. Well, what you should see is, for example, when we have, whoops, I'll make that in black, when we have humps like here, 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 and here, at all those humps, what do you notice? Well, you notice that the first derivative is equal to 0 at all of those humps. We have horizontal tangents, all right? So now let's look at these points right here and right here. What do you notice is interesting about the derivative there? Well, the first one I circled, this guy, that's a corner. This guy right here is a cusp, and what do we know about derivatives at corners and cusps? They are non-existent, okay? So immediately, if we want to start talking about extreme values, we got to start talking about derivatives and looking for places where derivatives are going to be either 0 or undefined, okay? Now, at the endpoints, there's a special trick to those, and there's also some things that I have not circled on this graph that we will come back to when we go over the definition of what a critical point is. So a critical point is basically any place where a derivative is 0 or undefined. And what we have is that functions take on these critical points take on these extreme values, which again mean maximum or minimum values. These only occur at critical points or at endpoints of the function. So basically, if you look at any function, it doesn't matter what it is, any place where that function takes on a maximum or a minimum is either going to occur at an endpoint if the function has endpoints, or it's going to occur at these critical points where the derivative is 0 or undefined. And that's pretty much what we saw from that last slide. If you want to go back, rewind the video a little bit, we'll go back to that slide in about 2 seconds. But if you notice, every single minimum or maximum value either occurred where that derivative was 0, undefined, or at an endpoint. Okay? However, there's a catch to this, and that catch is right down here, in that as long as we don't have an endpoint, if we have an extreme value, it's definitely going to be a critical point. There's no way we can get around that. However, just because we find a critical point, again, find a place where the derivative is 0 or undefined, that doesn't mean that we actually have an extreme value. So let's go back to the previous slide. And let's look right here. Now see if you can find any places on this graph where we have a critical point. Again, remember, a critical point is where the derivative is 0 or undefined, but we don't actually have a minimum or a maximum. Pause the video and see if you can find them. All right, so if you look for these points, hopefully you should see this one. We have a corner right there, but that is not a minimum or a maximum. Right here, we have a vertical tangent, but that is also not a minimum or a maximum. And right here we have a horizontal tangent, not a minimum or a maximum. In these first two green points, the derivative was undefined, making it a critical point. And in this last one, the derivative is 0, making it a critical point. However, again, we have that rule that all extreme values, as long as they are not endpoints, are going to be critical values or critical points, but not all critical points are going to be extreme values. So let's look at how we actually determine using critical points whether something is an extreme value or is not an extreme value. So let's first look at maximums, okay? So first of all, maximums are definitely going to occur at critical points where our derivative is 0 or undefined. But what we need is we need this sign change from, in this order, a positive derivative to either a 0 or undefined derivative at the critical point, and then to negative. So what do I mean when I say that? Well, let's look at 3 examples. Okay, one example is a hump. Here's our critical point where the derivative is 0. Anywhere to the left or the right of that critical point, our derivative goes from positive slope to 0 to negative. That's that progression I talked about right here. Let's look at a case where a derivative is undefined at a corner. Okay, our derivative at this point is undefined, but again, look to the right of it. The derivative is positive to the right and negative to the left. If we can look at our last example, where we have a cusp, again, the derivative is undefined at that cusp, but the derivative is positive to the right and negative to the left. So we're always going to have that pattern occurring whenever we find a maximum. Okay? There's also another way to find a maximum. It's called the second derivative test. And that's that if the derivative is 0, if we have a hump, a horizontal tangent, and the second derivative is negative. Recall that a negative second derivative means that we are concave down. So what that would look like is a frowny face hump like this. And at this point, our second derivative will be 0 because we are concave down at that point. And our first derivative, the second derivative will be less than 0. And the first derivative will be 0. So that's another useful test. Okay, these two tests are kind of interchangeable. Sometimes it's better to use a second derivative test. Other times it's better to look at that sign change of the first derivative around the critical point. Now, finally, we have those endpoints that we talked about. So if we got an endpoint, we're going to have a maximum at an endpoint if they look like this. So we'll look at 2 endpoints. These are 2 endpoints, a left and a right endpoint, that produce maximums at both of these points. But check this out. At that left point, our derivative is negative. At the right point, our derivative is positive. So therefore, we have a maximum at left endpoints when the derivative is less than 0 at that endpoint, and a maximum at right endpoints when the derivative is greater than 0 at that particular endpoint. And if you go back again to that figure that we showed in the beginning of this video, we'll see that that holds true for the 2 endpoints that we had right there. So let's now look at a case. Let's actually go back to that figure and let's look back here again. Let's look at these green points right here. Okay. Remember that I said when we're looking, in this case, for maximums, it turns out for minimums, we're looking for sign changes too. We want those sign changes around the derivative. Notice that to the left and the right of this, this green point right down here, our derivative is positive and then positive again. So we don't get that sign change. Whenever you don't get that sign change of the derivative around a critical point, that means it's nothing. It's just a critical point, but it's not an extreme value. Again, if we look at this point right here, to the left of it, our derivative is positive, and to the right, our derivative is positive. So again, we don't get a sign change, so there's nothing there. And we can say the same thing about this critical point. The derivative is positive to either side of it. So whenever we don't get a sign change, we basically have a critical point, but not an extreme value. All right? So now let's talk about minimums. And hopefully you can kind of glean from this that a minimum is basically just the opposite conditions as a maximum. They still occur at critical points when the derivative is 0 or undefined, but now instead of our sign change going positive 0 or undefined to negative, it goes negative to 0 undefined to positive. So if we draw our 3 examples up here again, you'll see that in every case, when we have these points, we have the critical point here, here, and here. The derivative is negative, negative, negative to the left, and positive, positive, positive to the right. It matches up with every single case. Likewise, we can also do that second derivative test. Okay, we have our critical point right here where the derivative is equal to 0, And since at that point the function is concave up, it means the second derivative is positive. So again, if you find a point where the derivative is 0 and the second derivative is greater than 0, boom, you know you got a maximum right there. Okay? Then when we go to endpoints, again, it's just the opposite condition of what we looked for when we were looking at maximums. And my mouse has totally disappeared on me, and it won't be coming back. And that's terrible. There it goes, finally. All right, that was Steve Jobs reaching out from beyond the grave and trying to get back at me for all the horrible things I say about his products in my class. Okay, so if we look at the endpoints again, in this case, if we want minimums at endpoints, both of these endpoints will be local minimums. And notice that the derivative at the left endpoint is positive, okay? And at the right endpoint, the derivative is negative. So we just have the opposite situations for a maximum. So again, to reiterate what we went over in this video, we found that maximums and minimums, or extreme values, only occur at critical points, and they only occur when, or I'm sorry, critical points and endpoints. And for the case of critical points, they only occur when our derivative gets that sign change between the left and the right of that particular critical point. So stay tuned for the next video. We will be going over some actual example problems to show you guys how you can find minimums and maximums of various functions.